SignalP. SignalP is a signal peptide predicting piece of software. Signal peptides are a small hydrophobic region followed by a couple of smaller amino acids, like amino acids with small side chains. And there's going to be a particular type of residue in between those, and that's going to mark the cleavage site. And all of this is predictable. What do you get if you predict a signal peptide? I can hear you saying internally. If it's got a signal peptide, it's going to be glycosylated. It's going to either be released from the cell or it's going to appear at the cell surface. So this is a good way to tell an intracellular membrane protein from an extracellular membrane protein, basically. So let's get into it. SignalP. It's got a big box. You put the thing in the box, and that's fine. There's a lot of the instructions are basically put the thing in the box. I know it'll take at least one at a time. I'm not sure if it takes more. Anyway, so you stick that in there, or if you want to just see an example, you can click there. I stuck in the SARS coronavirus 2 spike protein, which does have a signal peptide, or at least is predicted to. Let's see what it came up with. So, there we go. This is an example of a SignalP results page. And so what we've got here is predicting, all right, what do we have? What are the different parts? So an N-terminal and fine, a hydrophobic core, that's the orange bit, fine, high probability prediction. That's what this probability axis is. And then after that, it's got to have these small sort of cleavage residues. And then right at the end of that is where the cut is going to happen. And so since all of these parts seem to be there and seem to be highly predicted, it says that yes, 99.9% likelihood you've got a signal peptide on this protein, which is fantastic. And it turns out this one actually does. You say, well, it ends up on the outside of the virus, but it goes through the pathway as if it was going to end up on the outside of the cell, and that's how the virus gets its glycosylation, which turns out to be very important. So there you go. It looks for different kinds of signal peptides as well. These other four are very specific to particular types of things. You will not often see them, and you shouldn't see signal peptides at all in prokaryotic sequences, as far as I'm aware. There may be some archaea that have them. I am not sure. So if you're dealing with a eukaryote, you've got options, but if you're dealing with a prokaryote, probably not. And there we go, 99.9% chance of this particular one, which is the normal common signal peptide. There you go. That's SignalP, from input box to output result. And as with all these papers, if you want to cite it, they have the links to the papers built right into them every time. Thank you very much.